All right. So once again, I'm Laura Case. I am a co-investigator on the NCCIH-sponsored U24 network, Neurons Matter. Our mission is to build the field of research on the neuroscience of massage and better understand how therapeutic massage can benefit health. So I'll paste our link in the chat just in case anyone is new to this U24 network and might be interested. Just one second. Okay, there is our link. You can get more information and sign up for all of our talk series and upcoming pilot award applications and other exciting opportunities. So today we have the fourth talk in our virtual seminar series, and our speaker is Dr. Tristen Inagaki, who is an associate professor in the Department of Psychology at San Diego State University. Dr. Inagaki directs the Social Health and Affective Neuroscience Lab and is a mentor in the SDSU-UCSD Joint Doctoral Program in Clinical Psychology. Dr. Inagaki earned her PhD in psychology at UCLA, and before moving to San Diego, she was an assistant professor in biological health and social areas at the University of Pittsburgh. Her research focuses on neurobiological mechanisms linking experiences of social connection and disconnection in health, and she's very well funded by the Brain and Behavior Research Foundation, NIH, and NSF. She's also currently associate editor at Emotion and consulting editor at Health Psychology and a board member at Psychosomatic Medicine. And equally as I've had the privilege to experience, she's a wonderful collaborator and advocate for diversity in science. Since our network has been very focused on the mechanosensitive components of touch, I wanted to focus this time on the components of warmth that are also usually present in a massage interaction and how they may impact our health. So to that end, Tristen will give a talk on social warmth, body to mind influences on social cognition. And we will have the video will be recorded, and then we'll end right before the Q&A. And we have our previous speakers are posted at our website, and October 23rd at 9 a.m. we'll have Darren Lapoma, a chemical engineer and materials scientist who has also studied kind of how we perceive surfaces from a tactile perspective and chemical perspective. All right, so thank you, and Tristen, you can take it away.
Okay, thank you so much, Laura. Thank you for having me too. I'll just say that when Laura asked if I would speak to this group, I was just immediately intimidated and started sweating, and I haven't stopped since. But all that to say, please interrupt me at any time. I can't really see anyone, but feel free to unmute and ask questions or yeah. I want to keep it as casual as possible despite the Zoom setting. Okay, so I always start my talks actually with a little story by my favorite author, Haruki Murakami. So this is the story of Samsa in Love. This is a story about a bug who wakes up one morning to find that he's turned into a human. And he kind of has to learn what it's like to be a human. So for the first time ever, he has these thoughts. He has very new kind of perceptions and sensations. He has to learn how to walk on two legs. And for the first time, he learns the pain of hunger and the pain of being cold. And toward the end of the story, he meets this interesting other human, and he falls in love. And the story ends with this quote: just thinking about her made him warm inside. No longer did he wish to be a fish or a sunflower or anything else for that matter. He was glad to be human. For sure, it was a great inconvenience to have to walk on two legs and wear clothes, yet had he been a fish or a sunflower, he might never have experienced this emotion. So he felt. And I always start with this story because I love so many aspects of it, but I think it really highlights how deeply we as humans feel, and also how deeply others make us feel. And these are two topics that really interest me. So like Laura mentioned, I'm really interested in the experience of social connection, or affiliated and feeling connected with those that we love the most. But I'll argue that even though we know that connecting with others is this powerful and fundamental experience, we really don't know enough about why connection is good for us. And this is really important because, especially now, social connection is really under threat. In recent years, we've learned more and more about the prevalence of kind of disconnection and loneliness and isolation. And we've been alerted to the potential shrinking of our social networks. So these are just some infographics with apologies. Really, they're biased toward the US, but they're showing, Americans' social networks are shrinking and that more than half of US adults report feeling lonely, if not every day, at least once a month. So in order to better understand social connection and why it's good for us, and also how we might maintain those connections, I really spent the majority of my time exploring biological mechanisms and how social connection affects the body, and conversely, how changes to the body might subsequently affect social connection. So just returning to this, why is social connection important in general? So we know that connection predicts health and happiness and normal functioning and development kind of throughout the lifespan. But it's not just any connections. We really need strong, supportive, close connections. And, it's possible that we need those relationships or those connections in the same ways that we need air, water, and food. So in the same way that we have these basic physical needs, so too might we have these social needs. And if this is true, we work from the theory that if close relationships are essentially life-sustaining, then systems that support other life-sustaining functions may have been co-opted or co-evolved with the mechanisms that keep us socially connected. So we've focused on a number of these systems, the cardiovascular system, the inflammatory system, but today I'll focus on our work that looks at correlates of the thermoregulatory system, or in other words, the system that keeps our internal body temperature at a relatively warm state. So why physical warmth? We often use temperature-related language to describe experiences of social connection, especially those deep ones. So warm-hearted, the warmth of love, warm feelings. In recent years, we've also come to appreciate that the language we use to describe affective experience really does contribute to our subjective experience of those emotions. And the use of this warm or temperature-related language to describe social connection appears in nearly every known language. And this really suggests a universal human experience. We also know that warmth, and specifically thermoregulatory systems, that they are life-sustaining, or they're really critical to health and survival. So this is a really clean example from the animal literature. This was a study in which rat pups were separated from or deprived of, maternal care, food and water for 72 hours, and then they were simply just placed in cool or warm environments. And this is survival data, just showing that those placed in the warmer environments are living longer than those in the cooler environments. So same relative deprivation, the only thing varying here is the warmth of the environment. Data from humans kind of mirror these findings, right? So we know that premature babies that are raised in optimally warm environments survive longer than those in cooler environments. In humans, there also seem to be kind of stronger effects of what are called active warming conditions. So in the infant literature, at least, if you manually turn on and off one of those heat lamps above the infant. So if you kind of increase the just general ambient temperature of the incubator, those infants survive even longer than just the general kind of warm environment. You see similar effects in adults. So the picture in the middle is representing data from the ER transport literature. So patients who are transported to the ER for back pain report lower back pain if they're warmed with like an electric warming blanket compared to those that are just passively warmed with just a regular blanket that isn't actively warmed. And then maybe the strongest data was work that came out of Chuck Ryson's group when he was still at the University of Arizona. This was showing that if you experimentally alter or warm internal body temperature that can alter affective experience. So we know that patients who suffer from mood disorders, especially major depressive disorder and anxiety, that they also report kind of thermoregulatory symptoms, so sweating, higher core body temperature, things like this. But he has a few of these clinical trials just showing that if you whole body warming can reduce those depressive symptoms at the same degree as I think it's 6 months of SSRIs. So those are theoretically, those effects are theoretically working through those thermosensory pathways, sorry. Okay, so turning back to social connection and the possibility that warmth might share pathways with what we're calling social warmth, early data consistent with this possibility really comes from the famous studies done by Harry Harlow. So you may know that Harry Harlow separated infant macaques from their mothers and then placed them in a separate cage with a food-providing wire caregiver and this soft other caregiver. And the infants very famously chose to cling to the soft caregiver, which at the time was a real surprise, but it was really stressing the importance of contact comfort over other traditional needs like food. But a lesser known fact about the Harlow studies was that he also placed a 100-watt light bulb under the cloth mother, or the cloth caregiver, sorry, making them not only a source of contact comfort, but also of warmth. And, you know, that kind of very systematic process studies have not been done in human infants, but we can theorize that thermoregulatory systems probably contribute really heavily to monitoring social presence. So the presence of a caregiver usually means that that caregiver is actually physically present or nearby, and we aren't going to develop a whole new system or a whole new brain or a whole new mechanism kind of later in life to process something more abstract like the subjective experience of social connection. Instead, you know, connection may be built on these more concrete physical experiences to the extent that they're overlapping later in life. So to better understand the mechanisms that contribute to social connection, we really turn to the brain because the perception of warmth, at least, really originates in the brain. So up here, we're just displaying two regions, the ventral striatum and middle insula, because they've both been shown to activate to highly pleasing social stimuli, such as your own romantic partner or your own child, and also to physically warm stimuli. So we know that activity in these regions increase to warmth and social connection, and there is, at least in animals, some work suggesting that they play a causal role, right? So lesioning the insula leads to selective loss of warm sensation, whereas lesioning the ventral striatum reduces social connection behavior in animals. So we're particularly interested in these two regions going into studies on overlapping mechanisms. So today, I'm going to talk about 4 different studies, kind of briefly. The first 2 asking whether physical and social warmth share similar neurobiological pathways, and the second 2 will ask about the implications of such an overlap. So we'll start with our first study in this line of work. It was done during a completely different time in psychology. So we had 20 whole participants. This is an imaging task where in the scanner, participants completed this physical warmth task, a social warmth task, and a touch task, which I'll talk about in a bit. And afterwards, they report on their feelings of connection and warmth. Okay, so our warmth task, when we first kind of got into this work, was quite simple. We presented this as a product evaluation task where we asked people to hold warm and cool and room temperature objects. So they see this cue and then they hold just a warm therapeutic pack, one of those instant heat packs, and then they rest, and then the next condition goes on, and we have, I don't know, multiple trials of each of these kind of different temperature conditions. creating an experience of social connection. For those of you who have been in the scanner, that it's a very kind of artificially odd place to be, right? You're kind of lying on this flat, hard bed. Your head is squished into a tube and a cage, essentially. So it's not really a place where you kind of normally have a social experience. So for that reason, we had to kind of create this new task to elicit kind of realistic feelings. So we created this task that we sometimes call the messages task. We contact, I think, between 6 and 8 of each of our participants' close friends and family members. And we ask these people to write kind of positive, loving messages, sharing why they appreciate and love that participant. And then in the scanner, the participant gets to read these messages. It's a complete surprise. So they see a cue telling them who the messages are from, and then they see a couple of the messages, and then so on. And they get this whole collection of messages about why they're liked and loved. So I'll just show you a few of these messages. I will say the messages work better if you pretend like they're coming from people that you know. Otherwise, they don't feel as lovely. But here's just some of them. So here, thank you for loving me at my worst. You're my number one. Thank you for helping me be the best I can be. I'm so grateful to have you in my life, and I completely don't deserve you. You're a gift. And you are the bacon bits in our salad bowl of life. And I'll just say, people really love these messages. They come out of the scanner crying in joy, which is a real nice change for us compared to some of the other work we do in the lab. Okay, so that's our two tasks, our main tasks, our physical warmth task and our social warmth task. So now I'll just start by showing you those kind of post-scan readings, starting with the feelings of warmth. So you have each of the two tasks on the bottom here on the x-axis, and I've separated the tasks. So let's see, can you see my mouse if I go like this? Yeah, okay. So on this side, right, this is basically just a manipulation test. Sorry, showing that people are rating the warm packs as warmer than, in this case, a room temperature object. And then as some evidence that social warmth might lead to physical warmth, people also say that they felt warmer after reading those kind of loving messages compared to, in this case, they were reading neutral facts about themselves. And this makes sense if the detection of warmth is used as a proxy of social connection as well. Now, feelings of connection. So again, as hypothesized, let's see, participants are reporting feeling more connected to their loved ones after reading, that they're loved and cared for, compared to facts about themselves. Again, kind of a manipulation check for that task. But then for the physical warmth task, we also see this kind of tiny increase in how connected people are feeling after holding the warm packs compared to a room temperature object. And I know this is a very tiny increase, but when you think about kind of how non-social it can be to hold just a warm item in your hand, it's kind of an interesting increase. So next we look to the brain. We ran a conjunction analysis to show us shared activity to the two different tasks, to social and physical warmth. And the only two regions to show overlapping activity was the middle insula and the ventral striatum. And this was really exciting for us at the time because we knew based off of prior research that these regions were kind of involved in both experiences separately. So the glass brain is just showing you that these are the only two regions to show overlapping activity, and those are your peak coordinates here. So it does appear as if social and physical warmth might share mechanisms as the theory suggested. But one question here is, these are really just kind of two pleasant experiences. Are we just showing an overlap in pleasure, essentially? So this is where this kind of additional task came in. Participants also completed or were exposed to a task involving kind of soft stroking or soft brushing. And this was put in here to tease apart the effects of pleasantness or just doing anything kind of nice to the body. So here participants were kind of slowly stroked on the forearm for 10 seconds and then rested, or kind of touched with a dowel, so kind of neutral touching. And what was interesting here, so these are pleasantness ratings first, showing increases in pleasantness to kind of the primary condition to compared to each of the respective controls. So for the touch task, you have like increased pleasantness to brushing compared to the dowel, increased pleasantness to, warm pack compared to room temperature object, and so on. And you can see here that the touch task is actually increasing that kind of pleasure or pleasantness the most, and the most compared to the other two tasks. But we did not see overlapping activity between the touch task and social warmth, kind of suggesting that there really is something special, potentially about warmth when it comes to this kind of social experience. Okay, so now I want to back up and just look at the neural activity to reading the positive messages compared to the neutral messages, so just the social connection task. And you can see, increased activity, not only in the ventral striatum and the insula, but the pregenual cingulate. We had some VTA in here. But we know that these regions are not just specialized to warmth or just to social connection, right? And so I wanted to get a more precise understanding of the potential neurobiological overlap. And another way to get at greater precision is to ask, what is it about the voxels in these regions that's shared? So we took this other set of images from a study looking at mu opioid receptor binding in the brain. And what's interesting is that many of the same regions that are high in opioid receptors, as shown by the image on the bottom, are the regions that we're showing increased activity to in our social warmth task or in our experience of social connection. And this was especially exciting kind of as a side or a secondary kind of observation from this study, because that observation fits with this long-standing theory from the animal world, the brain opioid theory of social attachment. So according to the brain opioid theory of social attachment, the opioid system, which is best known for its role in euphoria and pain relief, but also for thermoregulation and cardiovascular control, so many other fundamental functions. So the system kind of might facilitate social bonding. So the idea here is that social bonding or affiliation or connection leads to the release of endogenous mu opioids, which leads to the pleasant feeling stemming from social connection. By extension, if you block natural opioid processing, that should reduce that subjective experience of connection. Again, I mentioned, this is a well-known theory from the animal literature. I'll highlight a few examples, but there are many, many others that have contributed to this work. So we know in sheep, lambs or their kind of offspring show a really clear preference for their own mothers after birth, but blocking opioids with an opioid antagonist eliminates that preference. So the lamb then moves from the mother to a stranger mother indiscriminately. You see similar effects in mu opioid receptor knockout mice, again, showing no preference for cues of the parent or the mother in this case. And we also know that blocking opioids decreases body temperature. And in the other direction, opioid agonists like morphine and fentanyl have really well documented thermoregulatory side effects. So flushing, warmth, sweating. Okay, so next we wanted to test kind of these ideas directly, that opioids might be involved in this social physical pain, warmth overlap in humans. So here we hypothesized that relative to placebo, blocking opioids would reduce warmth-induced feelings of connection and potentially disrupt that neural overlap that I showed you in the first study. So this is a double-blind placebo-controlled clinical trial with the opioid antagonist naltrexone. People are randomized here to drug condition, and then about an hour later, when naltrexone shows peak effects, they complete an MRI scan where they do those two tasks that I showed you at the beginning. I think the data I'm about to show you here is actually, after the scan, they report on their feelings of connection and report on their physical symptoms. So the opioid antagonist we're using is naltrexone or oral naltrexone. It's FDA approved for maintenance therapy for alcoholism and general substance use disorder. But we like it for research because it's safe and well tolerated with really minimal side effects. And in our studies, participants can't guess above chance levels whether they've taken naltrexone or placebo. It's a non-selective antagonist, meaning it affects all of the opioid receptors, but it has the kind of greatest affinity for the mu receptors, which is important for us because those are the receptors that are theorized to contribute to social bonding. Okay, so here I'll show you whether naltrexone affects those warmth-induced feelings of connection. So first you have, so those in the placebo condition, they did show kind of increased feelings of connection to holding the warm pack comparing to holding the room temperature or neutral object. So this is essentially replicating the finding I just showed you. And then what we found here is that naltrexone, to a marginal degree, did reduce those kind of warmth-induced feelings of connection in the hypothesized direction. Now the overlap between kind of the social experience and physical warmth, this is once again a conjunction analysis showing you each drug condition separately. So first in the placebo group, the only two regions to show overlapping activity once again in the entire brain were the ventral striatum and mid-insula. But in the naltrexone group, there was no longer overlapping activity. Rather, the only overlapping activity was in the superior temporal gyrus. So naltrexone here kind of erased that neural overlap that was present in the placebo condition. So those two studies are suggesting that physical and social warmth share opioid receptor dependent mechanisms. And, you know, if these experiences, social and physical warmth, really share mechanisms, our next questions are whether we can capitalize on this overlap to show that adding warmth to an experience of connection, especially with a close other, does that potentiate or amplify that experience of connection? So in other words, you know, if you make a close other physically warmer, does that heighten your experience of connection with that person? So this time, participants completed a scanner task where they view images of their own close others while holding warm, cool, and room temperature objects. And once again, after the scan, they report on their feelings of social connection and general pleasure to viewing those images. So here, this is, again, a 2x3 within subjects design. We're using it's a modified version of an art errand task, again, where you're looking at images of your close others. So if this task were made for me, you know, I'd be in the scanner while I get to view images of my own close other, Keanu Reeves. So I see a cue that I'm going to hold a warm pack, and then I get to look at Keanu for 12 seconds, and then I put the object down and I rest. And then maybe the next object is a cool or a cold object, once again, using these therapeutic packs, and the room temperature object, which in our case is just a squeeze ball. And then you also see gender, race, and age matched strangers as a control condition. So after the scan, here are questions assessing feelings of connection. How warm did you feel while holding this item? And how connected did you feel to the person in the photo while holding this item? And then feelings of pleasure. Again, we're collecting feelings of pleasure based off of the Lang and Bradley, 2-item questions. So how aversive did you find the pictures during this time, and how pleasant did you find the pictures during this time? And these are collected to see, again, if warmth effects are specific to feelings of connection or if they're generalizing to pleasure as well. Okay, so here are on the x-axis, you have the 3 temperature conditions: warm, neutral, and cool. And these are our feelings of connection effects. So you can see that physical warmth is influencing feelings of connection in this kind of graded pattern. As the objective and subjective warmth of the 3 objects increases, so too do feelings of connection. And I'll just say that this pattern holds if you adjust for the feelings of pleasure. but not the reverse. So you see kind of a similar graded pattern for feelings of pleasure, but if you then hold for feelings of connection, the three conditions are, there's no difference between the three conditions. Okay, now turning to the brain. First, we're focusing just on the two regions that showed shared activity in our previous two studies. So just the ventral striatum and mid-insula, that's on the y-axis. And on the x-axis, you have images of close others and images of strangers. And we found an interaction pattern here such that the warmed close other was increasing activity in both regions more than the same close other when holding a cool or a cold object. But those temperature conditions had no effect on brain activity to images of strangers. And there's two kind of more interesting simple effects here coming out of the interaction. So one is that the difference between activity to the warmed close other and warm strangers, so the two orange bars, is really just not present for the cold or the cool condition. So a cold close other suddenly at the level of the brain is no different than the cool or cold stranger. And the cool or cold close other is no different from a warm stranger either. So really these kind of three conditions right here are showing kind of similar effects. It's really about that warmed Keanu, warmed close other. So although maybe we can feel warmly towards strangers, physical warmth may be particularly relevant for existing close relationships or close connections, potentially. Okay, we also looked at activity across the whole brain to see what other regions might be increasing to a warmed close other. So panel A will show you regions that are more active to warm close others than warm strangers, and panel B will show you regions that are more active to the same kind of close other and stranger images when holding a cool or a cold object. Importantly, we're seeing increased activity in not only the ventral striatum, but the ventral medial prefrontal, DMPFC, pregenual and posterior cingulate. So regions traditionally associated with both reward processing and with social cognition, but also with social connection. And this is really in contrast to what's going on in panel B. So when holding a cool or a cold object, there's no differential activity in these affective or social cognition regions. So same close others, but no difference in activity between the close others and strangers when holding the cold pack. Instead, you just see this giant activity in the occipital cortex. All right, so I've taken you through, maybe we have shared activity between the two experiences, and then what happens at least neurally when you warm a close other. But there are a couple of issues with those kind of in-lab or in-scanner studies. One is that self-reported warmth and the way in which we're manipulating warmth itself is tricky for a lot of reasons, right? Reporting in particular is susceptible to demand characteristics. External warmth is not the same thing as the thermoregulatory processes that we're most interested in. And then you have all the artificial constraints of the lab and the MRI environments. And we also have this kind of long-term goal to understand the maintenance of social connection over time, not just this kind of single shot in the scanner experience. So in our next study, we wanted to know whether social and physical warmth, whether that theoretical overlap extended to naturalistic settings. So does body warmth relate to connection outside of the lab in a more naturalistic setting? So this is a daily diary or an EMA study where people are going to report on their feelings of connection and their current body temperature multiple times a day for an entire week. So 5 times a day for 1 week, people get a prompt asking them to report on how kind of in the moment, how connected and disconnected they feel. And then they record their tympanic or their ear temperature. I'm happy to talk about why we chose tympanic if anyone has questions, but tympanic, and they do this twice from their right ear, and they just record that. And then the results I'm going to show you, there are many, many covariates to control for in a study like this. But in this one, we're controlling for trait levels of connection, biological sex, ethnicity, and race, mean body temperature, weight, and percent body fat. So this is just an example from one of our participants. On the x-axis, you have those 35 measurements. On the y-axis, you have both tympanic temperature in Celsius. On this side is feelings of social connection. Higher numbers mean more connection, or warmer, normotensive body temperature, right? So first, what we see is that body temperature in particular, or tympanic temperature, is showing this kind of fluctuation within normotensive range throughout the 35 measurements. That's what you would expect. But our feelings of connection seem to be kind of tracking body temperature. So we're finding that feelings of connection, that when body temperature is warmer, feelings of connection are higher. And when body temperature is slightly lower or cooler, those feelings of connection are also lower. And again, this is adjusting for those covariates from the last slide. But this kind of a pattern really suggests that there might be a correlational relationship here, such that physical and social warmth show maybe a dynamic kind of corresponding pattern of responding. Okay, so here I've just shown you data to suggest that social connection might be built on mechanisms in the body that reinforce other basic needs, such as physical warmth and part of the basic reward circuit, endogenous opioids, and that manipulating either of these systems, warmth or opioids in this case, subsequently alters social connection. The findings also suggest that kind of daily experiences of warmth may also be relevant to our experiences of connection. And together, the results lend support for a larger neurobiological model of social connection as a really basic need on its own. We have a number of ongoing studies going on in the lab related to connection in particular, but I'll just highlight a few. First, with Laura, she mentioned at the beginning, we're working together to look at whether some of Laura's kind of effects on deep pressure might be relevant for connection experiences, especially warm connection experiences. So we're about to launch, I think that participant is being run tomorrow, which is really exciting, looking at whether deep pressure and warmth kind of jointly contribute to experiences of connection with close others. We're also interested in extending those kind of daily or naturalistic findings that I showed you. So with Kristen Lindquist at the University of North Carolina, we're looking at whether interoceptive sensitivity, so individual differences in interoceptive sensitivity, might moderate the relationship between that body warmth and social connection. So maybe those who are more sensitive show a stronger link between their own body temperature and experiences of connection. And then finally, I mentioned at the beginning of the talk that, folks living with mood disorders often also report thermoregulatory symptoms. So we've started measuring those symptoms in patients living with major depressive disorder and anxiety disorders. And we're going to see whether those symptoms relate to the neuroresponse to close others and to their kind of feelings of connection when they're in these therapeutic clinical trials. So this is work done with Charlie Taylor here at SDSU. Okay, with that, I just want to thank my collaborators on this line of work in particular, my lab, and our funders, but mostly you for listening. And I'm sorry, it's still very, very early for me. So that was a complete blur. Please ask questions, especially clarifying ones, especially if I was too fast. But thank you again. And thank you, Laura, for having me here.
That was awesome. Thank you so much, Tristen.
Sure.
I'm just going to turn off our recording and then we can do our Q&A.
Okay.